Here. I'm glad to see that you all made it. We're on page 345. Get that right up there in your face. We have already created the conversation and the note card supporting 30, 60, 90 triangle theorem. And I want to make sure that you see this information for the work we're going to do on page 345. And then on the 45, 45, 90 triangle theorem, that you go back to it. I just completed this right before recording this video, that this is a 45, 45, 90 triangle. I kind of used the protractor just to measure and make sure things were right. 90 degrees and then the angles. But this relationship of 45, 45, 90 creates what we're going to use today in this lesson in A to square root of 2. You might hear me say root 2 for short. Root 2a relationship. And we're going to practice that with 1, 2, 3, 4 examples. Here's the fourth one, right? I really appreciate this section. And you're going to see this math come back in Algebra 2, come back in Pre-Calc Trig, and it's honestly not that complicated. But for the first time that we see it, it can have some challenge. So I'll take it as quickly or as slowly as we need. I've also got in the background running some Desmos. And so you can see the calculations from that previous couple of videos. We're on page 345. We're going to use Desmos calculator to help us at least get some calculations. But here's the hint. We don't need it at all because we have decimal answers, which I don't want, versus exact answers, which I do want. Okay, you'll see what I mean. Let's go. This is 100% related to our learning targets on using 30, 60, 90 triangle theorems. Okay, I have my 30, 60, 90, 30, 60, 90 card, and I'm going to use the relationship on the back, which is why it's important to have this relationship. And then I'm going to use 2 highlight colors for this card so that I can actually show how the card and our questions line up. Let me talk about it. I'm going to highlight the short leg orange. That's across from the 30-degree angle orange. That's A. And I'm going to highlight the hypotenuse. That's the 2. I'm going to highlight it green. It's across from the 90-degree angle. So highlight the 90, highlight the 2. And I'm also going to highlight the reference to A. So what I'm going to write down for this problem, I need to go here. I need to highlight the hypotenuse green. Again, sorry if you're colorblind. Highlight the right angle, green. Highlight the short side. I know it's a short side because literally that's the smallest side. Highlight it orange. And highlight the 30-degree angle, orange. Once you have this set up and you know how it fits in with our shortcuts, then we're just going to write it out. We're just going to go ahead and put the structure 30, 60, 90, and then we're going to put A, root 3 times A, and 2A, lining up with the 30, 60, and the 90. And since those are orange, now I'm going to find, again, get some highlight in there, orange, orange, not highlighted because I don't have a third highlighter right now, but I'd highlight like blue or something, or yellow, and green. Now I look at my diagram, and I know that across from the 30 is 5 units, 5 miles, 5 inches, 5 whatevers. Line that up with A. Y is green because it's the longest side and it's across from the 90-degree angle. So I'm going to put Y in the same sorting place as 90. And then it leaves us with X. X doesn't have a highlight because I don't have a third highlighter right now, but I know that X is across from the 60 degrees, so X just goes in that stack. That's the setup, right? 5 should be orange, so all of the oranges should be there. Y should be green, so all of the greens should stack up, and then the not highlighted should stack up as well. Here's why we did this. A is 5, which means X, which is the square root of 3 times A, we get to replace A with 5. So therefore, easy peasy answer, the X is literally this expression, but make the A a 5. That 5. This 5 goes there, and it goes into that A. So write it down. Root 3 times 5. I should have gone with the easier one. A becomes a 5. So the 5 goes right there. That's the double relationship of the short leg to the hypotenuse. So if the short leg is 5, the long leg is 10. We're done with that question. If you had to, you could go to Desmos and do 5 root 3. So let's do that. 5, and then I'm typing SQRT, and Desmos converts that into a square root. See it again, SQRT 3. And I can write 8.660 on the page. Approximately 8.660. Cool. You guys, that's it. Does that look complicated? It's about to. Okay, same structure. This is a 30, 60, 90 triangle. So therefore, I'm going to use the 30, 60, 90 triangle theorem. This is B we're talking about now. And then in the 30, 60, 90 triangle theorem, I have this structure right here. Sorry, here's the pen kind of showing it. The 30, 60, 90, I'm going to write that down. You should always do this until you get like so good at this like being an automatic process that you don't have to. 30, 60, 90 degrees. And then I'm going to write down the bottom row. So I'm going to write down A root 3. And then I'm going to write down 2A. Okay. Bring in my highlight. Highlight the short side, orange. And that's across from the 30-degree angle. So I'm going to highlight the 30 in orange, and I'm going to highlight A in orange. Then I'm going to highlight the hypotenuse green. There it is. I'm going to highlight the 90 degrees green, because they're always across from each other. Then over here, I'm going to highlight the 90 and the 2A green. When I look at the triangle, the information from the triangle, well, X is orange, because X is in the same spot across from the 30 degrees. And Y is across from the 90, so I'm going to put Y here. That leaves 7 root 3 to line up with the 60 degrees. Now, I have to be very specific and careful going through this, but right here in this relationship, I see 7 and A exactly line up, and the square root of 3's exactly line up. So I'm going to say that 7 equals A. But if A is a 7, that means that the X and the A line up, and A is a 7. So X is 7. What more can I say? That's just how the relationship works. If A is 7, and the green hypotenuse is supposed to be twice as big as the orange X short side, then 7 times 2 makes 14. 2 times 7. We're done. I love this because of how simple this is, how direct it is. It has some challenge, yes, but we don't have to be too confused by it. Stick with the program. I'm seeing some issues with my dot cam. I need to reset it, which means I'm going to end this video. Part A done. Let's finish up part B in the next one. Bye.